Hey everyone, Michael Unger here with another edition of Ask an Astronomer, special edition because we do not have our regular astronomer, Marley. She's on a much needed vacation. So we've pulled in our head interpreter who's usually working on the floor. If you've been to the Space Center, you've probably seen him many times, and that is Matthew Cimone. Hey Matthew, how's it going?
I'm doing well. Thanks for having me on. I'll try to fill in Marley's big shoes.
I know, right? She's always diving deep, and we have dived deep to see what the space stories we have got going on right now. We're almost at the end of spring, sorry, the end of winter, almost spring. Equinox is coming up in a couple of weeks. We've got a big event to celebrate the Persian New Year, and that is Nowruz. So lots of exciting stuff happening here in the building on unceded territory of Musqueam, Squamish, and Tsleil-Waututh. But lots happening in the universe. We kind of like pulled a couple fun stories that we'd love to chat about. So we're going to get into that in just about a 30 seconds. But if you are out there watching on YouTube, on Facebook, on Instagram, jump on in and ask any question under the universe or maybe related to some of the topics we're going to talk about, or maybe not. We'll answer all comers. So let's get into this, Matthew, and let's chat about some fun stuff. Now, our first story that we're going to talk about is one that is near and dear, I think, to both of our hearts. One in particular, for me, I was born in 1977, so I've always felt that I've had a special affinity with Voyager. So why don't you go ahead and share your screen there, Matthew? Let's get into talking about some of these stories. What is going on with Voyager?
Yeah. So, all right, let's get our slideshow going here. So Voyager 1 and Voyager 2 were launched back in 1977. And these spacecraft are traveling farther now into space than any other vehicle that we've ever sent out there into the universe. And so, what's interesting about this right now is that Voyager 1's been running since we launched it in September of 1977. And now it is something's happened to it. And it's funny
Oh
because we
no.
talk about Voyager all the time here at the planetarium. We have images that that Voyager has taken of the planets, but also one of the really famous ones that we often show is called Pale Blue Dot, which is a tiny image of, or this little speck of Earth from super far away. And we always talk about it that it's this alive and active thing out there. And that, except lately, we've been saying, except up to a few weeks ago, when Voyager has now been sending basically junk data all the way back to Earth. So this is a picture here of Voyager looking back toward like the inner solar system. Voyager is like Voyager 2 is also one of the first times we ever visited the outer planets. So thinking about like Neptune and Uranus. And so if you've ever seen a photo of these planets up close, it comes from those missions. So it was like the first and only time that we ever went to the outer gas giant planets. Voyager 1 is now the most distant object humans have ever sent into space. So the fact that now something seems to have maybe become corrupted into its computers or memory system is kind of sad. But the legacy of it will continue because we always expected that one day the systems would die on this thing. But it's got this thing called the golden record on it. And that golden record has information and data from Earth. It's got people saying hello in like 30 different languages. It's got music ranging from like Mozart to Chuck Berry on it. And that will survive. So even if Voyager's computer systems die, this like arc of our civilization will continue zooming through space.
Okay, so Voyager is having a little bit of trouble. Now, both Voyagers are kind of like on the outskirts of the solar system. Were you able to share your screen again there, or was there
Yeah,
some
sure.
trouble?
Yeah. No,
Yeah, just
I thought I'll go back to that photo so we can see it again. Yeah.
yeah. So Voyager 1 and 2, maybe full screen it there so we can see the full photo. Voyager
Yep.
1 and 2 have they officially left the solar system? There's always been these boundaries that we always talk about of what's inside the solar system and what's not inside the solar system. So let's just talk about, like where Voyagers are right now.
Yeah, so we considered Voyager's both probes now to be outside of the solar system. So they're considered to be in interstellar space. And the boundary is a little bit fuzzy, but where we consider that to be is it's something called the heliopause. So think about that word like helio, thinking of sun, pause. It's like literally where the sun stops. So the sun emits all of these particles out into space. And what happens is eventually they'll reach a boundary layer at the outside of the solar system before they kind of turn in and sort of like stop radiating farther out into space. And so when we cross that boundary, we now consider ourselves to be in the space between solar systems. And Voyager 1 don't quote me on this now, but I'm pretty sure it crossed into interstellar space in 2013. So when that happened, that was like a monumentous thing. And
Yeah.
we knew that that had occurred because we could see that the energy from the sun quickly spiked and then dropped way off. And that was when we crossed that boundary out into the wider parts of the solar system. And so we're out there now. We have something from Earth, a piece of technology out there in space. And that made us wonder, like, if we encounter another civilization, because parts of us can go way farther than our biology can, maybe we'll bump into their technology before we actually bump into them.
Yeah. Okay. So amazing pieces of technology, and really, like, I don't think the original designers thought that they'd actually be still sending signals, in 2024. And that part of the problem is that these issues, those guys are still not around anymore. I mean, maybe they're still kicking it, but they're definitely senior citizens by now. So they're going to have to go back to some old manuals. I've heard that they've had to go back to like some very old manuals just to figure out how Voyagers are working, because this is basically 1960s technology, right?
Yeah, maybe they're pulling people out of retirement for this one. I'm not sure, but again, if it isn't a correctable fault, these probes have had a life and a legacy far outside of their original design. But I don't think that. I mean, I was a kid when Voyager was out among the outer gas giant planets, and I don't think even I fully appreciated at the time how amazing it was that those first images from those outer planets were coming in, and that we're able to see them. And I don't know if we also fully appreciate that the alignment of planets was such at the time that we realized, hey, wait a second, we could send two probes and we could bounce them between all the outer gas giants in one trip. And I think that alignment only happens like every couple centuries. So the fact that we caught it when we did is pretty amazing.
Amazing. Well, you know what's also amazing is that Marley's actually watching right now, and she's fact checked us. And Voyager 1 was 2012, and Voyager 2 was 2018, reaching interstellar
Thank you,
space.
Marley. That's why Marley gets paid the big bucks around here and why we feel her absence so keenly today.
Amazing. Okay, let's go on to our next big story is that you found for us, which is black holes, which is something that everyone loves, but we're talking about very big, large black holes orbiting around each other. What's going on here?
Yeah, so we know that these binary pairs of supermassive black holes, we call them. So there are three categories of black holes. So we have stellar mass black holes. They'll weigh like a few times the mass of our sun. And that's how we measure black holes in what we call solar masses. So how many times more massive is the black hole than our own star? Then we have intermediate mass black holes that'd be like a few thousand times the mass of our sun. But then we find these monsters, and they seem to reside mainly in the hearts of galaxies. So we're talking like millions to even billions of times the mass of our sun. We have one in the heart of our galaxy. It's called Sagittarius A star. It weighs about 4 million times the mass of the sun, so it's nothing to sneeze at. But these are monsters. So these two black holes exist in a galaxy that resides almost a billion light years away from Earth. And it's the first time we've been able to resolve two of them individually as they orbit around one another. So sometimes we find these black holes, these massive ones in these binary pairs where they're orbiting each other. Now, this isn't the actual image. This is an artistic rendering of what they look like. This is
Yeah.
mainly going to come through as data in our telescopes. But this is the first time we've been able to directly observe two of these massive black holes orbiting each other. And this is cool because we don't know necessarily how that might happen. It could be because galaxies have merged with each other, and so those two
Uh-huh.
big black holes are now meeting in the center. And we're observing these two. What's interesting about them is they don't seem to be getting any closer to each other like we expected them to. And so now we're trying to figure out what's the physics going on here that these black holes are not finally just spiraling into one each other to merge together. And I think the combined mass of these two is almost 30 billion solar masses, so big
Wow.
giants of the universe.
So this is a heavyweight fight. This is a two heavyweight fighters that are kind of just like stalking each other out.
Circling.
They're just like
I know.
sizing each other up. They're like ready to go at any moment, but they're not ready to dive in yet. And that's what we're still trying to figure out.
A few more million years and the match will begin, right? So we'll wait it out. But these things are monsters, and we actually don't know where these black holes come from, because if we look at the rates at which black holes could grow in the early universe, we still can't account for how big they are given the actual age of the universe. Like, they seem to be too big for how old the universe is. So we still have competing hypotheses as to how supermassive black holes have formed. Maybe some of these observations will help us to understand that.
Amazing, awesome. Well, our first question from Diego actually goes back to the Voyager mission. So
Hmm.
I'm not sure if I understand the question, but maybe we can figure it out.
Sure.
Should the info sent inside the Voyagers be updated in another mission? So maybe um, we send an update, to Voyager, I suppose.
Yeah, and that does happen. I mean, we do upload patches, essentially software patches to missions in space. I don't know when the last updates have been done to Voyager, but I'm assuming that updates have been sent to their software as well. So just like when you download patches in your operating system, your computer at home, we upload patches to update the software on the computers out there in space too. So we can do that. In fact, if I'm correct, at the New Horizons spacecraft, we uploaded names and pictures from people on Earth after the mission had already launched, and
Oh, wow.
they're now stored on that mission as it heads far out. It's another mission that's just headed out of the solar system.
Okay. Another question from Diego, now updating about the black hole. So we know that when two black holes collide, some mass gets lost. Where does that mass go?
Yeah, some of it gets converted to energy, and it gets radiated out as gravitational waves from the merger of the black hole. And it's amazing the amount of energy that can be put out by merging black holes that for like a nanosecond can sometimes overpower all the rest of the stars in the entire universe. It's wild. And now we can observe those gravity waves with detectors on Earth. So using laser interferometry, so like literally laser beams that are meeting each other
Yeah.
and kind of cancel each other out normally. But when one of these waves washes over our planet, it disturbs those laser beams so we can measure them. And it's these orbiting black holes around each other are one of the things that we're measuring the ripples through the universe from right now here on planet Earth, which is pretty amazing.
Awesome. Thanks, Diego. So let's move on to story number 3, which again is something near and dear to, I think, both of our hearts, which is the SETI project, a project that
Hmm.
I've been fascinated for a very long time. The SETI acronym, the Search for Extraterrestrial Intelligence, been around for a while, but we've got some cool new projects that are coming out.
Yeah, so there's SETI's announced a project called the Lipsoid, and it's really interesting. So I have I was trying to think of how an analogy for this, and I thought of a story that actually happened once when I was out stargazing at my grandfather's cottage. So my grandfather used to have this cottage in northwestern Ontario, and it was out there that I fell in love with the night sky when I was a kid. So back in 2011, it was this incredibly clear night. It was probably about 4 o'clock in the morning, and I'm out on the dock. He's got the cottage is out on the shore of a lake. It's super dark. I know there's cottages across on the other side of the lake, but I can't see any of them right now. Most of the lights are off. But all of a sudden, as I was standing there, I noticed this green cast all over the ground. And when I looked up into the sky, there's aurora like everywhere, just this
Mm.
intense aurora. So I'm standing up out there and I'm looking at this event. And then all of a sudden, I hear from across the lake this voice shout in excitement. And there's this guy yelling from across the lake. He's like, "Hey, does anyone see this? This is amazing." And he's yelling from across the lake. And then I yell back. I'm like, "Hey, I can see this." And he's like, "Isn't it fantastic?" And I'm like, "Yeah." So we have these two people yelling across the lake about this phenomenon up there in the sky. Well, that's kind of how this project is working with SETI. So SETI was like, hey, maybe aliens out there in the universe will synchronize their communication with us based on when we see something awesome happen out there in the universe. So, say, for example, a star explodes. Now, in this image here, Earth is on the right side of what is an ellipsoid, so the shape, that's why it's named this project. On the left, we might have something like a star blowing up. And then to the top left, we've got another planet there that has a little dish on it. Maybe that's some alien civilization. So as the light is traveling from left to right, remember, it takes time for light to travel through space. When the light passes the first planet, that alien civilization living there, they're like, hey, we see this supernova and we're going to beam a message out into space saying like, hey, does anyone see this? And then as the light from the supernova reaches Earth, it'll reach us as the same time as that signal that's now been added from the other civilization. So what we're basically saying is we're synchronizing communication. When we see a
Mm.
supernova, maybe we'll also then look through the data and see if we can find something that would be indicative of an artificial signal from another civilization. It's basically like that person across the lake yelling at me about, hey, do you see this thing in the sky? And we can say, yeah, isn't that amazing? And now we both know that we're out here in space seeing this thing together at the same time.
Yeah, it's very interesting, because a lot of the city projects, are based on the assumption that other species also want to talk to us as well, right? It doesn't
Mhm.
necessarily mean that there isn't species there. They may not even be like technologically capable if they're just microbes or whatnot. But we're talking about intelligent civilizations that actively want to talk to another civilization.
Yeah, and I would like to think that's maybe the case. That could be our own personal bias, but I would like to think that, as an intelligent civilization here on our planet, one of the things that drives us for science and exploration of the universe is wonder. And one of the biggest questions we have is there life out there in the universe? So I don't think it's a stretch to think that other civilizations out there are wondering this as well. And we need to find a way maybe to synchronize our communication. If the aurora wasn't happening and there was some person across the lake and they're yelling whether or not anyone is there, maybe I'm inside and I wouldn't have heard them. In that case, we
Right.
would have missed our messages. But if we find a way to synchronize our communication with each other, and maybe we can use events in the universe to do that, then SETI was like, hey, this might be another way that we can figure that out. In the past, we've done things similar before. So one of the first searches for life in the universe used radio signals at a certain wavelength, and it's 21 centimeters. And the reason why that is because 21 centimeters is also the wavelength that's given off by hydrogen, which is the most abundant element in the universe, and it's one that we often listen to already. So because it's a widely used radio channel, that's the one we started listening to because we thought, well, if aliens are listening to hydrogen as well, maybe that's the bandwidth that they're going to use to send signals on. So far, we haven't heard from anyone yet. Maybe we're
Right.
unpopular. I don't know.
Exactly. So of course, supernova explosions are kind of like what we're using here. Have we actually been able to see novas recently? Like I know that we talk about Betelgeuse being close. Um, is there? Do we have any data recently of novas? I mean, we have a question of like, can we see novas in the sky, essentially?
Yeah, I mean, sometimes they're bright enough to even see with the naked eye. I remember back in September of 2011, there was a supernova that occurred in a neighboring galaxy, and it actually was bright enough to be naked eye visible, even though it was in a neighboring galaxy, like super far away. We do see supernovae happen in our own galaxy. They happen about once every like century or so. We'll see explosions. There is an upcoming nova coming up that it might be visible to the naked eye that I remember seeing about. It's not a supernova; it's a nova. I might have to look this up really quickly while we're sitting here because I did hear about this recently. But it is not the explosion of an entire star, it's the explosion of material that is building up on the surface of a star. And I think it's coming up pretty soon. And the reason why it happens is that one of the objects, so in this case, it's a white dwarf star, is orbiting around another object, and material is falling on it on a regular basis. And so, at an interval of, I believe, about 80 years, there's a flash of material as it goes nova on the surface, and it will be visible to the eye. So I'm finding it here now. Let's see. Yeah, so the solar system is called TCRB. It normally has a magnitude of 10, so we can see it here, which is actually quite faint. You'd have a telescope in order to see that. And it's going to jump all the way to magnitude 2, which is wild. So to put that in perspective, every number of magnitude is 10 times brighter. So we're talking like how many math is bad for me sometimes. I think it's like 100,000 times brighter than it would normally be. So if you look this up, system TCRB, if you Google that, you'll probably find that in the next little while, between now and probably September, this thing is going to become brighter in the sky, and we should be able to see it even with a basic pair of binoculars. And that is material blowing up on the surface of another star at an 80-year interval that we can see out there in space.
Okay, very cool. Maybe just like stop sharing your screen there because I think we got a big black spot on the screen there.
Oh, do
But
we? Okay, sorry about that.
but let's go
I thought
to
we could see the web page together. I guess not.
well, maybe you could. I mean, I couldn't see it, but let's go to our final story here, which is the Space Telescope Live .org, which is I had not heard of this, but I started looking at this, and this is very cool.
Yeah, so I'll bring up this. There's a screen of the website here. Yeah, so this is spacetelscopelive.org. And so we've got these giant space telescopes operating out in space right now. So we've got the Hubble Space Telescope. We also have the Webb Telescope out there. And you might always be wondering, hey, what are they doing right now? Like, what are they looking at? Because there are like thousands of booked projects on both these telescopes all the time from researchers around the world. And if you're lucky enough to be one of those people, you can actually use the telescope for your own research. So you
Yeah.
can go to this website, spacetelescopelive.org, and you can literally click on the left side. What is the Hubble observing right now? Right side.
Should we click
What
it?
is yeah, what's it? Can we do I have it open right now? Space
Actually,
telescope.
I just started
Oh, you
sharing my
got it here.
screen.
Okay, cool. Yeah. So you can go on one of them and it's going to tell you what it's doing. So it starts fetching the target. It'll tell you the target category, the research program, and what's going on. Look at that. That's live. You can see that right now. That's what the telescope's
It's
doing.
amazing.
And it's amazing. It is amazing. And so these telescopes have they've connected with the public because obviously we see these beautiful images that come from the Webb telescope, that come from Hubble. But there's a lot of the times there are researchers that are just poring over data, and the data might not look as pretty because it hasn't been set up for, say, like public consumption in the same way. But if you're really interested in some of the nitty gritty research that's going on right now, that's still super fascinating, you can come here and look at it. And there's even the proposed research paper. So if you click on observation details there, Michael, to the right, there you go. It'll show, yeah, who's doing the research, when it's scheduled to start, the research proposal that got who the principal researcher is, all that stuff. So all that stuff is
Amazing.
there. So this is all this hard work that's being done by researchers around the world that are using these devices, and you can get a little bit of information in the investigations that are being done by both the telescopes right now. You can jump on at any time and figure out what both these telescopes are doing, how long they're going to be observing each of these targets, and why they're doing that.
Well, there we go. And JWST is looking at some black holes.
Yeah, I mean, why not? Actually, cool thing, we have a staff member here, and I don't know if they want me to share this, so I won't share names, but we do have a staff member here at the planetarium right now who is looking at Webb data, doing actual research. And it was funny because we were hanging out at the interpreter's office a few weeks ago, and they whipped out their laptop and they're like, hey, Matthew, do you want to see Webb images that no one in the world has seen yet? And I was like, yeah. And so they were studying the tidal effects of this really interesting tail coming off of another galaxy. And so I got to see some of that research data before anyone else did. It was a pretty special thing that our own staff are working with real Webb data and doing that research right here at the planetarium, which is kind of neat. Not research for the planetarium. They just work here at the planetarium. They're doing the work, I think, for UBC, but something to think about.
There you go. Well, that's what you're going to get if you come on down to the space city here and come and chat. You never know what cool things and new and novel things that you're going to talk about with our staff. So we've got our last few minutes here on Ask Astronomer. We'll go to about 4:30 Pacific time. So if you've got any questions, if you're watching out there on Instagram and want to chat with us, Facebook, YouTube, we've got a few more minutes here now, Matthew. We were chatting about a movie we both saw. We're both and hotly anticipated sci-fi movie, space epic drama, Dune 2, which I loved. What was your quick 30-second review of Dune 2?
Oh, it was amazing. So everyone, you should go see it. It's a cinematic masterpiece, and all sorts of interesting themes are brought up in Dune. So we got human science and technology, but also like culture, politics, religion, and all this stuff. And people who know Dune, it's the best-selling science fiction novel of all time, written by Frank Herbert. And so the second half of it has now come out from director Denis Villeneuve. I guess you saw it as well. What did you think of it?
Well, I mean, I was just blown away, especially by the look of it. And, there was one scene in particular that I kind of had to pause, and kind of like, what is going on here? Because it certainly was not something in the book. It was a creative liberty that Denis Villeneuve put in, which was when we went to the Harkonnen homeworld. And we saw their homeworld for the first time, and it was all in black and white. And they mentioned, under the black sun. I'm like, what on earth is a black sun? And,
Right, yeah.
Afterwards, I was thinking about it because its striking was very visual and very different than some of the other worlds. But I started thinking about it a bit more, and I thought, well, the only reason we get color is because of visible light. So perhaps a black sun is only emitting an infrared light, and I was like, is that even possible? What do you think?
I don't think so. So I mean, so we got a picture of a star here, and in order to be a star, you have to be undergoing nuclear fusion. So the if you do have stars that emit most of their energy in infrared light, and so that is possible. They are red dwarf stars. So red dwarf stars, tiniest of stars we see, and actually the most abundant star in our galaxy. So we're getting now around to the size of Jupiter. So the smallest stars and the biggest of planets to kind of overlap in terms of size. So most of the energy emitted from a red dwarf will be in infrared light, but it still will be a lot of energy still emitted in visible light. So there still is going to be visible reddish light being emitted from that star. Interesting thing around the light, though, that as it finally hits the planet, is how would that change, say, the evolution of life on a particular planet? What would chlorophyll be like on a planet orbiting a red dwarf star? Maybe it would be a much darker in color to absorb all the energy that it possibly could from that star. You might have black or purple chlorophyll on a planet that orbits a red dwarf star. Now, whether or not you'd have all black and I mean, you still, even in black and white, there's still light there. So there's some kind of visible light coming. But it did make very interesting and striking artistic choice in the film. And my understanding is that the Harkonnen in the books was supposed to be reminiscent of like the Soviet Union. And I wondered if sort of the artistic choice there was to try to make it look like old war footage type video. It's that we typically see in black and white, and I wondered if that's why they had done that in the film.
Yeah, and of course, in every iteration of Doom, they kind of like add in a little bit more lore, and the Harkonnen are always kind of like the most interesting, and of course, like they're, the Baron Harkonnen, filled with gas, is kind of just like this bloated creature that we saw in a couple iterations where he kind of like floats up to the ceiling, and you see him in Doom 2, kind of like going to this pot. So really, really striking. Definitely go see Doom 2. Marley says that it needed more worms.
It needed more worms. Yeah, there were far more worms in the first film. I thought the worms were going to be a little bit more present, but there are a couple really good scenes with the worms when they finally use them as to attack the Arakeen, the capital city on Dune. But visually stunning. I've seen it twice already in theaters. Likely will end up going again. So if you enjoyed the first half, this one is really good, and certainly I would say probably a better installment of the films than the David Lynch one. So,
although it didn't have a Sting, basically almost naked except for a weird codpiece.
Yes, that is true. But you did. And what kind of an interesting thing about this is Sting played Fade Harkonnen in the previous movie, whereas this guy, I can't remember the actor's name off the top of my head, but he's the one who played Elvis in the Elvis biopic that was done. So you still have two famous musicians, I guess technically, that played the same character in two different iterations of Dune. So that is a thing, I guess. There you go.
Yeah, and
that was great film.
That was a good final showdown as well at the end there. It was a really good cool knife fight. That there's so many cool technology in this film. And thank you, Matthew, for jumping in. Last minute here. We had a busy day. If you folks are out there, want to come and visit us, we've got so many cool programs coming up. Like I said, no ruse. There's still tickets on sale for that on March the 16th. And just on sale, we just put up onto our website our next Cosmic Night. That is our 19+ event that's coming up on April the 18th. And that is where we are going to be bringing in special guests from the podcast, The Illusionist, which is all about language. And if you listen to the podcast, The Illusionist, Helen Zaltzman dives deep into all sorts of subjects, kind of looking at the history of where language comes from, how it's evolved, how humans have kind of adapted language. So, of course, if The Illusionist is coming here, we're going to talk about the language of space. So that just dropped on our website. That one's probably going to be a hot seller. So if you want to come to that one, get in there. And those tickets, I think early bird tickets are probably available for April 18th. So hope to see you all there. And I'll see all of you here on the next edition of Ask an Astronomer. Marley will probably be here on March the 21st. We'll be close to equinox. Maybe we'll even have an equinox episode. So until then, we'll bid you adieu. Take care, everyone.